Hey, thank you for coming back to my channel. It's good to see you here again. Today, I would like to introduce you to a problem or to a scenario that led to a problem um, in a production environment that I work with. So I have this client, they were running on Exadata generation X7. They were running out of storage. I think they had like 6 months worth of storage space available in their existing production Exadata. And they were, as I said, on X7 generation. That um that alone already says something because X7 was already, at the end of its life. That was like a year and a half ago or something. So actually, this was 2.5 years ago. They when we started discussing this, right? So I suggested them, let's start discussing our options with Oracle and see where we can move. Like if we go with the newer Exadata generation, if we go when we expand the existing infrastructure, and then we went to Oracle, we explained the situation, and they come up with some suggestions. And the client opted for, going with the newer generation of Exadata, Exadata X9M, or suggested going with Exadata Cloud at Customer, which I'm not going to comment on that right now. That's a topic for another discussion. And the thing is that the client was having me in these meetings in the beginning, and then we started discussing the options. I recommended him specifically not going with Exadata Cloud at Customer, so I recommended going with Exadata on premises. Then I was pushed out of these meetings for a while, like for 2 or 3 months. And once the deal was already done, I was invited back in. So the client chose to go with Exadata Cloud at Customer because of the cost benefits. And again, this is a topic for another video. What I wanted to say is that the client made the deal based on vendor and on their own people assessment and recommendations. And they ended up um, not choosing the right path for them. So they bought new X9M hardware, that's much more capable compared to the X7 that they had. But they went from, I think it was 7 or 8 storage servers in production. With the newer generation, they would have more disk capacity, and they were running out of storage, as I mentioned. So the disks in the newer generation are larger. So on X7, the disks were 10 terabyte large on the storage servers. And on the new X9M generation, they were 18 terabyte large. So it has 80% more capacity just because the disks are larger, but it doesn't have more disks, just have more capacity on disks. So they made the decision. So we don't need 8 or 7 storage servers in the new production. So we will go with only 4 because that will have a cost reduction and licensing and hardware that's needed. That's the way they chose to go with only 4 storage servers because they would have more capacity, all the capacity that they needed because the disks were larger compared to the previous generation. That was enough for them, and that was like what they did. They signed the deal, and then I was invited again to the calls and all the discussion, everything. So at the time of the migration, so in the time of migration came, I started my assessment. So I started analyzing the environment, checking I think here and there, see if they would be, you know, able to run all their workload in the new Exadata environment. And I realized that, you know, as I mentioned before, they were not only running out of space, they're running out of I/O power. Although X9M has these persistent memory cache on X9M, Uh, so they have, a lot of power for OLTP workload. They would also have less storage servers, which means less I/O power. So they were going from, I think it was seven storage servers to four storage servers. That's like almost half of the power that they used to have on the X7. The disks themselves are not faster. They are like spinning disks, rotational disks, right? Hard disk drives. Hard disk drives, they have, limited physical I/O power, and the disks are not faster. They're going from X7 with high capacity disks to X9M with high capacity disks. So the more power that they get is only from the persistent memory cache and from the CPU that are, newer and faster. But I/O wise, they would have less I/O for analytical workloads, which was their main workload on these Exadata. Most of their workload is uh, I/O hungry in regards to throughput and not latency. So they would gain more latency power or faster response time on the X9M because of persistent memory cache mainly, but they would have less I/O bandwidth or I/O throughput in the new Exadata, less IOPS because they would have less storage servers. Then I told the client, this is a bottleneck for me. I mean, I can migrate to your new environment, but I'm pretty sure that we're gonna start facing performance problems right after the migration because your workload is more OLAP than OLTP and this and that. And I explained all the situation, all the bits and pieces that were involved. And I anticipated that, we will also have less flash cache capacity. So flash cache is the flash disk drives or SSDs that are available in Exadata storage servers. So in a high capacity Exadata storage server, you would have 12 hard disk drives or 12 spinning disks and four SSDs or flash disks. So these four flash disks, they would build what is called a flash cache. So in a X7 generation, you would have, I think it's four 6.4 terabyte flash disk drives that will give you, I think it's around 25 terabytes of flash cache space, while on the X9M, you would have the same space, so 25%, 25 terabytes per storage of flash cache, but you would have less storage servers, right? So we went from seven storage servers to only four. So instead of 100 and how much is that? 175 terabytes of flash cache, we would go down to less than 100 terabytes. That was not looking good in my perspective. So the client told me, the deal is already done, is already signed. We have to migrate. There is no option. There is nothing we can do. We were migrating using a switchover approach. So I built a standby on the new Exadata, and then we would just switch over. So in case we needed, we could switch back to the previous environment. So, it was just a, primary database here, standby being built on the new Exadata, and then I just switch over the workload to the new Exadata, and then we would maintain the old Exadata as a standby. Then we could easily switch it back. The client decided to move on because, all the pain and hassle that we were already going through, so we migrated. And guess what happened? Yeah, you're right. It started having performance problems right after the migration. So initially I said, we need to run maybe a couple of hours or something like that because the cache itself, the flash cache itself is cold. We need to cache more data in and see how the system behaves. I cannot like immediately switch it back because we have to accommodate to the workload on the new environment. We did that. We ran for like 2 days after the migration, having performance problems. The client said, no matter what, I need to run on this platform. I have to decommission the old platform. We have to run on the new platform. We have to fix whatever is in place that is affecting us. And then I told the client, the problem is with this Exadata, we have less flash cache capacity. Majority of your workload is OLAP, so it doesn't take advantage of all the flash cache capacity because flash cache and persistent memory cache, those caches are made and make more sense for OLTP-like workloads. In this case, they had, a more OLAP workload. So they were being affected because with less flash cache available, not all their sorting, hashing, joining of tables were being kept in the flash cache. They had to go to the hard disk for that. So that was causing problems. So when I was checking the AWR reports, I could see that the global reason for thrashing was because well, was large write trashing. So all the large writes were not being kept in the flash cache because there were so many, so much large writes on these flash caches that they couldn't keep in in the flash cache. They were thrown out and flushed out to disk. So all the scans, all the joins of tables that couldn't be done in memory or in the PGA memory area, they would be thrown to be done at the disk layer. And the disk layer, they would be first cached by the flash cache, but they had less flash cache available, so that would even go down deeper to the hard disk drives, and that's much slower. That's like 10 times slower than performing these operations in the flash cache in the first place. Um, so they started having problems because of that. So we opened an SR with Oracle. Since this was Exadata Cloud customer, we didn't have direct access to the storage servers. Therefore, I couldn't go there and change the parameters, right? Like the storage server parameters, how they behave and things like that. So I know there were like 2 or 3 parameters that I could change to change the flash cache algorithm to cache more temp related data in the flash cache. So that's what I suggested to Oracle. Can't you guys just change, the storage service parameter that affect this behavior of the algorithm of the flash cache? So we keep more data, more temporary data, or we allow more temporary data into the flash cache area that we have. Since we had less storage, we had less storage, less flash cache space, we needed a more broad or a wider area for temporary data to be cached in the flash cache. So, as our comments go, come and go, and all the back and forth with Oracle, they put the storage server parameters in place to change the behavior of the flash cache, and then all the problems went away for a while, right? So they went away right after the migration. A couple of months later, as the workload increased, the problem came back. And then I finally convinced the client to, buy more storage servers so they could have more I/O power and stop having these type of hassle. So long story short, uh, whenever you're performing these assessments, helping a client to migrate to new hardware or things like that, get the client to work with you closely. And I really like this client, but they had a new manager. They were trying to do things a little bit differently, and we ended up in this situation. But always try to talk to your clients, do the proper assessments and guide them through the correct way, because if they don't do that, you're gonna suffer, the client's gonna suffer, their end users, their customers are gonna suffer as well because of all these performance problems that the environment is facing. So after a while, maybe, I don't know, 6, 7 months, environment is stable. And now this has been like, this was in, I think, around November, December 2023, something like that. And, since then, the environment is stable, everything is looking good. We don't have major performance problems anymore. because now the environment is at the size that it should be in the first place. So keep that in mind. Thank you for watching. Stay tuned for next videos. I appreciate your support. Hit the like and subscribe to my channel and share this video with your friends if you think it's useful. Thank you.